What is up, ladies and gentlemen? Welcome to day 65 of OnShape. We're going to be making a herringbone gear system. Now, herringbone gears tend to be a whole lot sturdier than just straight up spur gears for a whole variety of physics reasons. What we're going to do is we're going to create a herringbone gear system. I'm actually going to print this one because I already got it queued up on the Cura for my Ender 3 on the Cura Slicer software. More in that video later, but we got to make it first before we can 3D print it. What I'm going to do is I'm going to make this pretty quick and then kind of talk about why I'm doing certain things when it comes to when we 3D print anything we make. So let's go ahead and hit the plus icon, create Part Studio, and make our two gears. Now when it comes to our gears, you can create your gears first. I actually probably recommend that you create your gearbox first, just because I have a little bit of a lag issue. Once you create these spur gears, OnShape tends to run a little slow, or I would say it has to go through a lot of processes really quickly. And sometimes if your internet's not quick enough, or if you're working on a low processor or low powered computer, you can just have a little bit of an issue. But I'm gonna make them first, and then I'm gonna make them a gearbox. But if you are on a Chromebook, I recommend you do the reverse. Make the gearbox first. Okay, so we got a Spur Gear feature script. We got 25 teeth. I'm going to keep all of that the same. The only thing I'm going to add is a depth of 1/2 inch. And then on helical, we're also going to click double helix. So what it's going to do is it's going to go through all the processes of modeling this helix gear for me, or this herringbone gear for me. And there we go. We created it. Boom, done. Looks great. Let's go ahead and take our working planes and make them inactive. What I'm also going to do, what sometimes gets in the way, is I'm actually going to make the sketch for that spur gear inactive as well. Something about it is just going to get in the way, and this is why this is like take 25 for this video. All right, we're going to do the same thing again. We're going to create another 1/2 inch thick gear. We're going to give it 100 teeth instead. Do the same thing, create a double helix, center bore, but we're going to give it a counterclockwise threading. The reason being is that when these herringbone gears interact, one of them is going to run clockwise, the other one has to run counterclockwise, or there's going to be a direct overlap on the gear of the teeth. You could fix this in the assembly by just flipping it around, but I figured at least showcase it here and make our design process a little bit smarter rather than having to work harder. All right, let's go ahead and click transform. I'm going to go ahead and move this gear box, or this spur gear down so we can make our gearbox. So we're going to click on transform. We're going to translate in the X, Y, or Z direction by 2.5 inches. Now I've already made this, so why did I choose 2.5? Well, the diameter of our big gear is 4 inches. So that means its radius is 2 inches. And the diameter of our smaller gear is 1 inch, which means the radius is 1/2 inch. So 1/2 inch plus 2 is 2.5. And this now creates the correct, I would say, spacing between our two gears for them to interact. Now you can see that the teeth would work better, but there is clearly an overlap here. We're going to fix that in the assembly. I'm not worried about it right here. Let's go ahead and create that, make that sketch inactive though for that 100 tooth gear. Try again. And then we're going to build our gearbox around it. But here's what I recommend. Make these inactive. When you build your gearbox, you don't want any pieces you don't need. And so for me, I've just found out, and this is why this is take 25, if you have those gears active, it's just going to give you a headache. It's going to accidentally choose the working planes, the wrong things to extrude, the wrong things to interact. Sometimes you're going to accidentally reference geometry you don't mean to. And it really bogs down the system. So I recommend is that if you know what you need, don't reference it, just make it. So here's what it is saying. I know what I need. I know I need 2 holes that are 3 inch thick for my axle to run through. We're just gonna actually just go ahead and make this whole thing and throw in our dimensions, and it'll fix what this should look like. What I do know is that these gears are also 2.5 inches apart. You're like, oh no, is everything okay? Yes, things are okay. Just to make for the sake of symmetry, I want the axle on the right side to be an 1.5 inches in, and the axle on the left side to be 1.5 inches in. Now when I type in 1.5 inches, it does that. That's not what I want. So I actually found out something recently. You can type in a negative dimension and it'll throw it the other way. I thought that was cool. So if your dimension, when you throw it in, goes the wrong direction, just type in a negative and it fixes it. And then as far as the distance from the top, let's give it 1/4 inch. That doesn't look good enough. Let's give that, let's give it 3/8 of an inch. That looks good to me. Looks cool. We got 1/2 inch, 1/2 inch, 1/2 inch. Everything looks okay, but I need to give it some more height. And we're already almost fully dimensioned. So you see, by roughly throwing that geometry in there and throwing in my dimensions of what I need as it goes on, notice that all of my lines are now black, which means they are all fully constrained, meaning there's no unknown dimensions left in the system. So when I go and throw some other things in there, like let's say another rectangle, it's not going to affect any of my other already dimensioned geometry. So for example, I want this to only be a 1/4 inch from the bottom, and so it'll throw down the bottom line. But the height, I don't want 3 inches. I want to be able to see in here, but I don't want it to interact. Uh-oh, we're throwing some automatic geometry. Let's fix this. Let's try this again. I talked so confidently. Let's do the other way around. That's right. Here's what we run into when I actually creating videos. I run into problems where I have to figure out, well, what went wrong? And here's what went wrong. By drawing that rectangle, I referenced it to the center of this circle, and it threw in automatic geometric constraints. I don't want those. I don't like them. So instead of going through the hassle of it, I'm just going to hit Control-Z until that rectangle's gone, and then be a little bit smarter about where I draw it at. And that's not at the center point. See, that's what I'm talking about. That's what I'm talking about. I'm sure there was a quicker way to make this, but this is what my design flow looks like, is that instead of looking for the most effective thing, is how can I fix my problems as they're going along. I'm sure there's somebody who's more effective at creating design and having a solid workflow, but this is just what works for me. Let's go ahead and extrude that box out. That looks good. And we have to take a chunk out of the top for it to fit our gears into. So let's do another rectangle. Let's do a corner rectangle. And this time I do want some automatic geometry. I want these, so you see how this line over here is black now, is because they threw in an automatic parallel constraint, meaning that this line is parallel to the line that's on top of. It's not going to move. The only thing I need to change now is how thick, the height of what that rectangle is going to be. Now our gears are 1/2 inch thick, but I do want a little wiggle room, so let's do a little bit more than 1/2 inch. Not much, just a little bit. And you're like, okay, what am I going to do to make sure this is equal though? And here's why I just, CAD, if you understand how the system works, you can have it do things for you really, really well. So I could get a piece of paper out or figure out what this number could be to make an equal side on both sides. You could plug and chug away, or you could know the math. Well, I know this is 1 inch in height overall. I know 0.55 of it is going to be what we're going to clear out. And I don't want to evenly split between two things. So I'm just going to take those two numbers, divide by 2. Boom, there you go. Like I said, there's probably an easier way to do it, but I just want to showcase some things just so you aren't locked into only being able to use a certain amount of tools. All right, let's go ahead and extrude. Let's remove for, I believe it's going to do about 3.25 inches. And that looks okay. You know what? Let's give that a little bit more thickness because I do want it to have a little bit of a sturdy base. And we're going to see if there's any gear interactions later on. You know what? I'm going to change one other thing before we go back. Let's go into this sketch and let's bump up the thickness of these walls just because it looks a little flimsy for me and I don't know if I would like where it's at. Cool. That looks just a little bit better. We've got our gearbox to hold our gears. So I'm going to click on the plus icon. Let's hit create assembly just to see if we run into any issues. So I'm going to insert Part Studio 2. Hit the check mark. Let's do a revolute. See if this revolves around. I just want to see if there's any interaction between the spacing there. And it looks good, like there's going to be a good enough clearance for that bottom side. That looks good. We're going to do one more revolute. Get that 100 tooth gear out of my way so I can look at this one. Looks good. We're going to flip it. Make sure that our teeth are not messed up on the directions they're going. That looks great. Only thing we need to do now is throw in our handles. Let's just do a gear mate while we're at it. 1 to revolute 2, so it's a 4:1 ratio. So I should be able to type in 4. Click play. And now if I animate this, what went wrong? And this is something that I see a lot of students do, is that they get so confident on the revolute that they forget to ground something. What is not going to move? And that's going to be our gearbox. I didn't name it. I forgot to do that. Let's fix it. There we go. So we hit right click, fix, and that allows us to see our gearbox interact. What's the problem? Well, they're not going the right way. One of those should be going counterclockwise. So let's reverse direction. Now let's hit animate. I'm going to animate the second one. Should be a little slower. Let's do a loop. Click play. And that looks pretty good. Oh, beautiful. Don't even need to fix the mates. It's working exactly as expected. Okay. I am at 14-minute mark. So here's what I'm going to say is, I think you guys can make a handle on your own. I don't want this video to be too long. Here's the one thing I want to do when you're thinking about 3D printing stuff. And that is to add chamfers and to create things in such a way to when you 3D print them, that it is all stackable. So notice on my handle here, I've got my handle and my axle. My axle is going to print as part of an insert to the handle, but the part you're actually going to turn, the crank of that handle, is a separate 3D print. And that allows me to create everything with minimal supports. And that's what I'm shooting for, is that when I 3D print something, I want minimal supports. We could make the argument that we could print this on its side and you might produce less supports. But what I want to see is, what is the strength of this gearbox when I print the layers this way versus the other way? Future video coming up later. But for now, here is where we are. When you're creating something you want to 3D print, and it's going to be mechanical in nature, you might want to disassemble your design in such a way to where everything is printable as the least amount of supports needed. And so we do that by chopping up our pieces. So the gears are pretty easy to think about and printing with no supports. But my handle and axle, we broke into two separate pieces, like I mentioned earlier, where we're able to print it as one piece. We're going to have to assemble it later, but it has no supports needed. And I found this just to be more helpful because when it comes to supports, they just tend to be a waste of plastic, and they also leave a slight residual to making it hard for pieces to fit the way they're supposed to. So if we had some support connecting this axle, it might not actually fit into that bore hole very well right here. So I imagine I might have some sanding or clearing out to do for this hole right here. All right, guys, that's going to be it for this video. If you have any questions, let me know. Hopefully Herringbone Gears have been fun for you. At least they were fun for me. We're going to print this in a video coming up here soon. Stick around. It'll probably be available sometime in the next week. All right, take care, guys.